A rational function is when you take y equals p of x. That's just, oh, come on, don't do that. How do I make it stop? There. All right. Anyway, is when I take one function, p of x, or it could be f of x, or g of x, or h of x, divided by some other function, q of x, or something like that. A function divided by another function. It's called the parent rational function. This is the parent function. Remember, a parent function is the most basic function of the family. So rational functions can look like anything, but they all have a kind of a standard basic shape or form. Remember, the parent function for linear functions was y equals x. So for linear functions, the parent function was y equals x. That was the simplest linear function you could have. The parent function for quadratic functions was y equals x squared. That was the parent function for quadratics. And so each family has its own parent function. This is the parent function of the rational function family. Of graphs of rational functions. So one major characteristic is asymptotes. Asymptotes are lines that the graph gets really close to, but never actually touches or crosses. So here, in the parent function, in the parent rational function, y equals 1 over x, if you were to graph it, you would have an asymptote. Oh, mommy. Oh, yellow's a bad color. All right, you would have a horizontal asymptote. Right, horizontal means kind of left, right with the horizon. Horizontal asymptote at y equals 0. That line, the graph is never going to cross. We'd also have a vertical asymptote, an asymptote that goes up and down at x equals 0. Right here, so the graph is never going to cross that dotted line. We typically represent asymptotes by dotted lines. Right, so that's in the parent function where the asymptotes are. We'll spend a lot of time trying to figure out where the asymptotes are. And what that means for the domain and range. Asymptotes are a line that the graph approaches as x or y approaches infinity. All right, so as x gets really big, or really sorry, as x gets really big, or dotted line, sorry, as x gets really big or really negative in either direction, the graph will not cross the line. Okay, you might remember these from exponential functions, right? There were asymptotes in most exponential functions. And this one has obviously a horizontal and a vertical one. And notice that this is a kind of a modification of y equals 1 over x. This is 6 over x plus 2, so it kind of shifts the graph around and changes kind of how drastic the curve is here. We're not going to get into that a whole lot, but that it is just a modification of the parent function 1 over x. Function. The first function's graph.
Wait.
Oh. Wait, I'll show you it again.
No, wait.
Oh. Okay. So that's the graph of the first function, and I want to figure out where the horizontal asymptotes are. Well, this one is pretty straightforward. I'm just going to look at it, and maybe if I had zoomed out, it would have been a little bit more obvious. But I'm looking for horizontal asymptotes. That means like the horizon, right, left and right, and it looks like it goes through. Right about like that. Okay. That's the horizontal asymptote. The horizontal asymptote for the first function is at y equals negative 1. All right? Y equals negative 1. You wouldn't just write negative 1. If you just put negative 1, I don't know what that means. The asymptote is a line that goes through y equals negative 1. So when you write y equals negative 1, I know, okay, you're talking about this line right here. It's never going to cross that line. Okay, so once again, quick recap. If I have a linear function divided by a linear function, right? If you just look at this, 1 or x minus 1 is linear, 2x minus 3 is linear. Then I just look at the leading coefficients. In this one, it was 1/2, so that was my horizontal asymptote. In this one, it was 3, so we'd have a horizontal asymptote at y equals 3. I'm not going to take the time to draw that whole graph in, but we could at least know that that's where the horizontal asymptote is. Okay. Questions on finding horizontal asymptotes? I want to write this down. Write down vertical asymptotes. They occur when I divide by 0.
Only you?
Well, if you write I on your paper, then it'll work for you too, Jack. Yeah, so So check this. I'm taking the denominator, the bottom of the fraction, and I'm saying, when is x minus 2 equal to 0? Question mark. I want to know when that is. Well, if I add 2 to both sides, that happens when x equals 0. So right then, that's not right. How about x equals 2? All right. So right then, I know there's a vertical asymptote. Vertical means up and down at x equals 2. Let's check. This is the graph. Does that seem about right? It's pretty close. All right. And if we check the table on this graph, I think that's what we would find also, is that we never have a y value that that is 2. Or excuse me, an x value that is 2. It should be undefined there if we checked our table. Okay. Oh, now that the vertical asymptotes occur whenever I divide by 0. Well, when is the denominator 0? That's going to happen whenever 2... Oh, no.
Whoa. Whoa.
Hold on.
Those are some nice
Here we go.
got going there.
Yeah, thanks. Whenever the denominator, 2x minus 3, is equal to 0. Well, when is that going to happen? When is 2x minus 3 equal to 0? Let's solve it for x. I'm going to add 3 to both sides. So I get 2x equals 3. And if I divide by 2, I'm going to get x equals 3 divided by 2. So the vertical asymptote should happen at x equals 3 over 2. Okay. So in the last one, there's a vertical asymptote at x equals 3. And if you graphed it, you would hopefully would see that.
That's pretty convenient.
Yeah, I thought so.
Wait, so how do you find
Think about that in the range. The domain of the function, remember, that's for what x values is there a function value. So here's how I look at the domain. I go through a bunch of x values. So let's try like x equals negative 5. And I check, is there a function value or a y value right there? Well, at 5, yeah, there's a y value right there, sure. Then I go through and I check, what about at like negative 2.5?
Oh yeah, that's the one value.
Yeah, what about at 0?
Oh yeah.
Yeah, that works. What about at 2?
Oh no.
No, there's no y value at 2. That's where my asymptote happens to be, right? So right here, there is no function value. So is x equals 2 in my domain?
Oh yeah. No.
It can't be. Yeah, right, it can't be, right?
No.
Every single number worked except what number?
2.
2. All right, so my domain is all real numbers. You pick any real number, it's going to work, except that x better not be 2. That's a problem. I'm dividing by 0. It will create a small tear in the universe, and I don't want to be responsible for that. Range. I usually start from, let's do a different color here. I start from the bottom in the on the y-axis, and I start moving up, and I'm checking values. And I keep going, I notice that the function has y values at negative 5, it has it at negative 2, it has it at negative 2.5, it stops here. Alright, so the range is not going to include that value. And then if I keep going up, though, I think I've got, notice the green graph has y values all the way up. So the only part in the range where the y values don't exist is this horizontal asymptote, which we figured out already was where?
0.5.
Wasn't it negative 2?
How could it be negative 2?
Or negative 1, I'm sorry, negative 1. Right? It's at negative 1. Okay. So for my range, it's all y values, so it's all real numbers, except that y cannot be negative 2. Alright, so my domain is all real numbers work beautifully, except the vertical asymptote. My range is all real numbers work beautifully, except the horizontal asymptote. Questions on domain? In number 2, we said we had a horizontal asymptote at what? 1/2, right? Y equals 0.5, or 1/2. And we had a vertical asymptote at x equals,
1/3.
wasn't it 1.5? 1.5. So we already figured all that out, okay? So now I'm thinking about my domain and range. Domain. All right, in fact, you know what? Let's just draw in the asymptotes real quick. Y equals 0.5. That was like right here.
How do you find the vertical?
And it's wherever I divide by 0. And x equals 1.5. That was right here.
That's true.
Okay? So if I think about the domain, all x values are going to work. In fact, let's do this. Let's make the pen really big. Oh, this will be good. So I'm going along the x-axis. All of these x values are going to work until I hit where?
Right there, right there, right
Oh, stop. Pick up your pen and keep going. All these x values are going to work beautifully. So my domain then is
That.
all real numbers except what?
That.
X can't be
0.5.
1.5.
That's true.
Okay. For my range, go through the range. And oh no, I'm going to erase my domain, but that's all right. I don't care. And I'm going for y values. Keep going until I have to pick up my pen. Whoa! Stop.
Pick it up.
Pick it up and keep going. All right, what value did I leave out?
0.5, sir.
So I left out 0.5. So it's all real numbers. Oh, mommy. All real numbers except x can't be, or excuse me, y can't be. Y can't be 0.5.